Thank you for giving Wellesley Municipal Light the opportunity to talk about its renewable energy policy. As you can see, we're in the process of installing solar panels on our new garage and warehouse. Back in June of 2009, we applied to the Department of Energy Resources for a grant for this installation. In March of 2010, we were awarded that grant. We then contracted with Austro Electric to do the installation. This is a 50,000 watt AC solar panel installation. It'll supply enough energy to run the garage and warehouse during non-peak times. It will also have the ability to feed back into the grid when the solar panels produce excess energy beyond what the garage and warehouse will use. This is also an expandable system. We can add more panels as time allows. On the roof, there'll be 280 solar panels, each producing about 205 watts of power. Each panel is about 3 feet by 5 feet, and the weight of each panel is about 41 pounds. The panels are wired into an inverter, which will take the solar energy, convert it from DC voltage to AC voltage, so that it can be used in the garage and warehouse. The inverter is also connected to the grid system, so when the excess from the garage and warehouse can then go back into the grid. There are several other solar installations in Wellesley. The existing high school has a 2 kW solar installation. The new high school is proposed to have a 40 kW installation. The cost of the project is $261,000. $150,000 of that will be funded by the Department of Energy Resources, and the Wellesley Municipal Light will fund the remaining portion of it. We expect these panels to be in service for 20 years with minimum maintenance. Although the cost of a kilowatt produced by solar energy is more expensive than a kilowatt produced by conventional methods, we anticipate that this solar panel will reduce the town's carbon footprint by 45 tons a year.
This is the inverter manufactured by Solectra Renewables, and what it does, it takes the DC power produced from the panels and converts it to AC. Through a sequence of electronics inside, it allows to change that DC power into AC. Right now, in the front of the inverter, we can look at a little display which displays the energy being produced by the system. As you can see, we have produced around 4,584 kilowatt hours, and all that power has either been absorbed by the building or it has been put into the electrical grid. We are able to reduce the energy that we have to take from the power grid by whatever power the solar system is producing at that particular moment. So being able to have the solar system producing allows us to not be able to take that amount of power from the power grid.